Welcome, everybody. Thank you so much for coming to our tour today. My name is Rianne Janovic. I am 21 Acres Administrative Assistant, and we're so excited you're here. We are here with Kelly Rankich, our Facilities Manager and Lead Green Associate, and Chris Paulson, our Facilities Technician, an overall lifesaver for every team that we have at 21 Acres, from the soil team to the farm market team downstairs. Saves all of us. So he's going to be filming Kelly today, and we'll probably speak a little bit as well. We're really grateful you're here. I'd like to share a small bit about 21 Acres before we get started on the tour, and then I'll hand it off to Kelly. Here's a little bit about 21 Acres. So we are a living laboratory which serves to educate our communities around climate change and how to participate in climate action. And we do this by promoting and building resilient food systems that are rooted in agroecology and regenerative farming, sustainable land stewardship, and adopting sustainable living and building practices. 21 Acres is located in Woodinville, Washington, and I'd like to give a land acknowledgement to where we're situated. We are on the ancestral lands of Indigenous nations, including the Stillaguamish tribe, who are part of the larger Duwamish and Coast Salish peoples. We acknowledge these nations and people as the original stewards of this land, and we honor both the land itself and the Duwamish and Coast Salish people, past and present. Without further ado, I'm going to hand it off to Kelly to introduce the tour. Thank you for learning about us today. And I'll be in the chat.
I'm gonna put my phone away for a sec. So again, my name's Kelly. Like I was trying to say, Chris and I have been here for 2 years, and because of that, I do still rely on my notes because I haven't been doing that many of these building tours, so apologies in advance for that. And to kind of cue off of what Rianne was speaking to you about the 21 Acres mission, you know, we inspire action to solve climate change by learning as a community to grow, eat, and live sustainably. And those three key points are why we're here on this tour. So living sustainably is about this green building and green energy. If you're interested in growing sustainably, we also have our farm tours on the 4th Saturdays of the month. And you two aren't local, but we do, if you want to eat sustainably, we would invite you to come to our market anytime you're in our neck of the woods. We have a farm market that's open downstairs 4 days of the week. So again, you're in a 12,000 square foot LEED Platinum certified building. And here is our gorgeous plaque. We achieved the certification back in 2013. There's a number of ways that you can achieve points in order to earn the platinum status, which is the highest status that they are able to give out. And the different categories that you achieve points in include where your site is located. So if you're near public transportation, you can get points for that, for example. Water efficiency as a whole category, and we'll talk a bit about water efficiency on this tour. Energy, of course, and a couple people in the that had signed up for the tour were interested in energy, so we'll definitely focus on our energy saving systems here. Materials and resources, so it's getting locally sourced materials, recyclable or salvaged materials, and other things that help with indoor air quality, such as low VOC paints. We intentionally do not have a lot of carpet or any carpet. We have some rugs that are washable. And then innovation. So if you have innovative designs, you can get extra points in that category for your LEED certification as well. There's other questions about LEED specifically at this point? I guess I know you two are muted. If you could use the chat if you had any questions about LEED. The program here that puts it on is called the U.S. Green Building Council. I know there's a lot of international programs. I've been looking at International Passive House, for example. So you might be familiar with that one.
I have a question. What did it take for you to get certified as a LEED associate?
My Green Associate, yeah. So LEED Green Associate is the entry level accreditation for a professional, and so I studied. I studied and I read. So there's study materials, and then you take a test. So, and it was during COVID, so I took an online proctored test. And then the next level is called an AP, or an accredited professional. And when you do that, you get it in a category. So LEED has categories such as O&M, operation and maintenance, or there's like new construction, B, D, and C. And it could be for a remodel. So I'm gonna have to pick a focus for my next one, and I need to get on that, and I need to get my study materials and start studying. So, because that's important to me to get my AP.
Yes, good luck.
So thanks for asking. Yeah. So one of our favorite features here in terms of energy efficiency is our energy monitoring system. It's called EGauge, and we're gonna walk you over here to our monitor. This is a system that's called a circuit monitoring system. We have clamps down on the circuitry in our electrical room that monitor all of our, well, we have about 30 subloads that we're monitoring. So in addition to our subloads, we're monitoring our solar. So this green right here, and this is just a beautiful, so this is a 1 week shot. So you can kind of see the diurnal pattern of our solar energy that we're getting from our solar panels, which we'll talk about in a little bit. So all of this green shading is energy that we're producing but not using on site. And so we're turning that to the grid with net metering. And we get credited for that on our utility bills. This kind of white shading here is the solar energy that we're using on site. So the red line is our energy use, our total energy use. So right here is when we're using solar to provide energy for our building. And this is the energy that we get from the grid. And then the fun part, all of these little toggles down here at the bottom are the circuits that we are monitoring. And if I toggle them all off, one of my favorite circuits to show, oops, sorry, I gotta toggle them back off again. Is our dishwasher, just because it gives you a nice idea of the energy use of our dishwasher and gets little peaks. So when it heats up the water, it's a highly efficient dishwasher that's Energy Star rated, but when it kicks on, it does use a decent amount of energy. So we can kind of keep an eye on things around here. If there's a problem with the system, EGauge helps us identify it and rectify it. We noticed that half of our solar panels weren't functioning. And so by watching EGauge, we were able to get that issue resolved right away. And we also use EGauge to monitor our patterns. When one of our employees saw how much energy the elevator was using, which is a low energy elevator, it uses about 70% less energy than a typical, I can even show you that one. Someone just went on the elevator too, so we can usually watch the EGauge.
It's all catching up again, but
there's quite a bit more. Okay. Rianne, I heard you guys lost me for a sec.
Just for a sec, but we're back now. What exactly are you showing right now? Is this the elevator?
This is the elevator use. Yep. So actually this will show you, we actually had our elevator go down. So this little gap right here is because it actually stopped working for a 24-hour period or so. And then we got it fixed, and we're back on using it again.
This is such a useful tool for especially commercial buildings, but they also have residential applications. And I sent a link into the chat for folks who might be interested in checking this awesome system out. You can also see the prices of your energy use per month. I'm not sure how we have it set up, but
right here, yeah. Are you talking about up at the top here? Yeah. So this graph shows us the energy that we used in this time frame. So right here, I happen to have picked a week. So we have used 1.34 megawatt hours of energy this week, and you can tell what our solar panels have generated as well. So our solar panels in the summer produce about 45% of our energy needs during the summer, but annually it comes down to being about 18 to 20% of our energy use annually. We are a building that has a number of refrigerators, so we do have a relatively higher energy use than a typical building. And then here's the monthly that you were referring to up here. Yeah. Do we have questions about EGauge or energy monitoring before we're gonna head outside and let Chris talk a little bit more and show you our solar panels and talk about our living roof and how we manage water here on the property.
Awesome. Yeah, if any questions come up of past topics, since we're asking you all to type now instead, we'll funnel those in at a good time.
Okay, so we're going to transition outside, and I'm going to go ahead and film Chris while he does his
Thanks again for sticking with us.
About our living roof. I'm going to mute myself.
But we'll get it back. It kind of loses it for a second. And Chris, we might need him to unmute if he's talking. So I've spotlighted Kelly showing Chris.
Oh, there we go. Hello, everyone. Can you hear me?
Yep,
Okay.
You sound great.
My name's Chris Paulson. I'm the facilities technician here at 21 Acres, and I'm going to tell you about the living roof that we have, which will have a 3D picture accompanying this info. And as you can see, we have two main sloped roofs that have been fitted with a like a big honeycomb mesh that retains a high drainage soil replacement called substrate. And this this stuff is specifically referred to as extensive soil media or substrate media, and it's seeded with a type of succulent called sedums, which are drought resistant. This system helps with a number of things with our building, including cooling the building just with the excess biomass, carbon locking with the amount of plant matter growing up there, and it also helps to slow stormwater that will come coursing down in any rain events or snow before it goes into our gray and black water treatment system that we have on site. All of the water that comes into this facility is treated on site and returned to the water table here. It gets filtered through a aerobic and an anaerobic process and pumped out to these Glendon biomounds that we have out near some orchards. So they feed our apple trees. And yeah, it's a closed, well, I guess it's an open system. It's just a one-way system that brings water in, or from our pump that we have, or a well that we have to pump to offset our agricultural water use with the sustainable farm that's in the back 17. And yeah, I guess we could go to the 3D picture, which we have here. Good, I can comment on this. Rianne will be panning right to left. You can see our living roof here with the sedums, and this picture was taken in either fall or early spring, and so a lot of the plant matter is kind of like idle right now, but it blooms right back into this massive sea of flowers. Here you can see some of the solar array. We have a 25 kilowatt solar array on the roof. That's half of the array right there. The other half is on the other wing of the building, along with the translucent, what do you call it? Skylights, which are a very special insulated, it's an R20 value skylights, which we'll be able to see from the inside in a minute, that helps to naturally light our building while retaining heat inside of the building in the winter months. Very useful during the winter months. But yeah, that's our green living roof.
I'm gonna
Thank you.
or mute.
So then I'm gonna spotlight Chris's phone again.
Okay, can you hear me okay?
You sound perfect. Thanks everyone for sticking with us.
Yeah.
And
He
we
was
did
getting
have
a little. Oh, go ahead.
We had a comment from Emilio who says, "Is this a green roof, right? Tetto verde in Italiano, insulated
Ooh,
from
that
hot,
sounds a lot
cold,
better.
to moisture." That is
Tetto
correct.
verde?
Tetto verde. I love that. That sounds amazing.
Yeah.
And that is
green roofs or living roofs, help with the transpiration of the water, helps with the cooling. But also just any kind of a cool roof, which is any light color, helps with the heat island effect. So we realize that many buildings and many residential homes can't, they have to be structurally engineered in order to support a living roof. But the alternative to that is to be sure to try to aim for light. And we, even our pavement and our pavers everywhere, we try to aim for light building materials to help with that heat island effect. So because I'm on Wi-Fi, I kind of need to stick close to the building, but I was hoping that Chris could show you our FRU. Hopefully his signal's a little bit better. We happen to love what we call our FRU, which is a post-harvest refrigeration unit. It's an insulated walk-in cooler, and we have what's called a food hub here. So farmers can come and bring their produce and store it in this cooler. And then it gets distributed to nursing facilities and schools and other areas. So we're kind of like that go-between, because a lot of farmers don't have the ability to keep their produce cool. The FRU is constructed out of what are called SIP panels, or structurally insulated panels. They are OSB boards with kind of a styrofoam type foam in the middle. And then the outer layer of the FRU, if you can see that, is made out of 2-inch thick cork. And cork is really the latest and greatest in sustainable materials. It is actually not harvested. It's not harvested in terms of cutting the tree down. You actually harvest it by shaving the bark of a tree. And then it becomes a carbon sink. So everywhere, we're trying to find ways to get carbon out of the atmosphere and keep it out of the atmosphere. And using cork is a wonderful way of doing that. And this, the FRU here is heated with a heat pump. And so heat pumps are basically like we're tricking it. It's kind of like almost like an air conditioner, but we tell it to cool it extra low so that it keeps the temperature in there that's appropriate for produce. And I'm going to step away to see where Chris ended up. Oh, he's kind of zoomed in on the FRU. Our FRU was originally designed to support to get a certification in the Living Building Challenge, but would have needed to have solar panels installed on top, which was the original intent. But somewhere along the way, we ended up having to pull out of the Living Building Challenge for the FRU. So Chris is going to come back up here. Do you want to show? And we have permeable pavers down there.
Yes.
Permeable pavers are great for slowing down stormwater runoff and help to filter the different contaminants and debris that can come off of cars. That's an easy thing that people can incorporate at home.
I feel like that's my favorite sustainable technology, is how we've incorporated the permeable pavers into the bioswale, because we are bordering a pretty good size small city right next to the farm, and we introduce, we're the buffer between the city and the whole farmland of the Sammamish Valley. And even actually, Chris, one more thing, could you show the terraces pavers down there? Because you can actually see them this tour. They're the building is built on a hill, and all of these cracks, all of the little grooves in between the pavers allow for the water to filter and go directly back into this hill. That also helps cool the building and was designed all well. But whenever we have flooding here in Seattle, or Washington, which is every, other season, there is never an issue in our parking lots. Like, all of my friends' apartments last fall were flooded, and our parking lots were giving back to the ecosystem, which was amazing. Anyway.
Yeah, we do also have, on that note, speaking of flooding, we do have 4.5 acres of wetlands that we are restoring and maintaining here as well. So we have a lot of features that we're doing to try to help purify the water before it gets back down into the water table. Thank you, Rian. So really quick, while we're out here, we want to talk a little bit more about passive solar, and Rian referred to our earthen berm. So yeah, we are built on a big berm. I don't know if you could have seen it when you're out and about that way, Chris, but the berm is helpful. It helps keep the building cool in the summer and helps retain the heat in the winter. And with that last heat wave we had, yes, the building got very, very warm upstairs, but the downstairs was quite pleasant. And I remember telling a friend I was wearing a flannel, and while I was at work, and she was quite jealous. And then up here, I'm gonna make Chris go all over the place. Oh, you can show them, I guess, while you're down there. You guys can see the gray water, or the treatment system, the black water and gray water treatment system that we have in our berm. There's a number of tanks and blowers that are treating our water on site that Chris was referring to earlier. And a couple other things out here for passive solar has to do with window placement. And how we do shading. So when Chris gets back up here, I'll show you our trellis system. I know that's also one of Rianne's favorites. It was designed, yeah, it has a couple of functions. But we have an overhang. Overhangs are important, and this one specifically, this wall is our south-facing wall. And so in the wintertime, we get a lot of solar gain through these windows that helps keep the building warm and doesn't rely on our geothermal heat system. And then in the summertime, it's designed so like we're almost at the highest point of the day. At the highest point of the sun in the summer, we get the shade, that overhang that goes almost all the way down to the base of the windows, and the sun's going to go up a little bit more. It lines up just about right to shade right to the bottom of the windows. And then the trellis is designed, we haven't planted it yet, but we want to plant vines that will grow and have their leaves in the summer to help shade the building, and that the leaves will then fall and drop in the winter and allow that solar gain that we desperately need to help keep the building warm. And you can see these solar shades on the windows. They block an enormous amount of heat from the building. And from the outside, they're very opaque. But what we're gonna do is we're gonna step inside and let you see when what they look like when you're on the inside. They're very translucent. And having screens and operable doors and windows is another thing that you can do to really control your energy use. We'll show you what those solar screens look like from the inside. Thank you, Chris. Do we have any questions about the FRU or our passive solar water treatment?
Not at this time.
Not right now.
But
okay.
If you do, just share them in the chat if anything comes up, because there is a lot of material in here. And I will be sending a follow-up email as well with some links to show some of this material in action in other places.
Yeah, and we tend to not get to everything on the tour, especially with our little our little extra guest that jumped in. So let me know. There's some of the things we have a hard time getting to are the composting toilets and our geothermal heat system. And we have our kitchen. So you could put in the chat. I'm going to keep talking and keep taking on the tour, but you could put in the chat if you want to vote for any of those in case we run out of time. So Rianne, we're going to come in right now.
Oh yeah, sounds good. I will.
You might want to mute.
And we did have a question I'll ask.
Okay, you can stay. Okay. Okay, so that was Rianne. This right here is our Great Hall. You can see it has clear story windows, which bring in a lot of natural lighting. It's such a pleasant workspace for occupants. It helps increase their health and well-being to have a lot of natural lighting, and it reduces our need to rely on energy. There's a lot of features in here about lighting. So we have sensors that control our lights. One is in this upper, okay, that one right there is the light sensor. So we have a motion sensor that will first tell you whether someone's in the room. And then we also have a light sensor that will then look to see if the lights need to come on. So anything that you can do to automate systems at your place of home or work greatly reduce your reliance on energy. And then we were talking about the skylights. Chris was showing them. This is what they look like. These are by a manufacturer called Calwell. They're filled with a nanogel. They provide the same amount of insulation as a wall, a typical wall. So they can be, the new ones are up to R20. As by reference, a window itself provides insulation around an R1 or an R2. And then another highlight of our building that people love to learn about are how the building walls were constructed. These are called insulated concrete forms, or ICF. It's 2 layers of styrofoam with these plastic inserts that are used to hold the rebar. And then the concrete is poured inside of these forms here. It saves a huge amount of concrete in the construction of the building. And then it also saved a lot of styrofoam from going into the landfill. I think I was trying to find my stat here. I think it's 17,000 pounds. So yeah, 17,000 pounds of styrofoam were kept out of the landfill by using these insulated concrete forms. Are there any questions about these topics?
I have, we did get a question about the living roof. And before we do that, I was wondering, is there I feel like I just wish that there were more of these kinds of materials that were used in buildings. Do you know if there's any like initiatives in Seattle that are asking folks to make sure new construction has something like, you know, has an aspect of diverting waste into their building code or anything? It's kind of a far out question.
Yeah, and that's funny because I actually wanted to dig into that a little bit more before this talk today, but I ran out of time because I don't want to say anything wrong, but I do know the city of Seattle is, I don't know this, I won't be able to quote the stats perfectly, but they're requiring lots of new construction, and I can't remember the criteria to use the Built Green certification. So I think they have to have a minimum of 3 stars. And Built Green has 3, 4, or 5 stars, but that's a very local thing that's specific to either Washington State or King and Snohomish County here. But then the other thing we're doing out here in Washington is the Washington Energy Code. They just started enforcing the new code and doing like having a really high thermal envelope for your building, which these provide, and HVAC systems, heating systems, I guess it's the distribution, how you distribute your HVAC and the source of energy for your HVAC. All of those things are now required as part of our Washington State Energy Code. So people are going to be forced to start incorporating a lot more green building once they start looking at these submitting building permits under the new code here in our state. Does that
makes me
help,
so happy to hear.
help answer? Yeah, City of Seattle is definitely cutting edge, in my opinion, on their requirements for green building. So, and my philosophy is, unfortunately, it does kind of take, Chris isn't going to like my spiel. It does kind of take government, in my opinion, government intervention and regulations to start that ball rolling. He's laughing at me. But once that ball gets rolling, you create the market. So you have to kind of have that requirement, and things cost more in the beginning. They're less available. People don't know, like we call ourselves a living laboratory here. And, you know, Chris and I are you know, fixing a lot of these systems because they were new and innovative. Someone's got to do it. And the more it gets done, the more you learn, and the more people do it, the prices come down and things get better. Batteries will get smaller and so forth.
That is such a good point. That kind of feeds in well too to like exploring the unknown with a lot of these new systems. We had a question in the chat that asks, what does it take to maintain something like a green roof? And I know that there's been a lot of new successes and a lot of challenges that are super important to share about. So that was a really good question from Han, and I'm too curious to learn.
And this is an incredible time to ask. And Chris and I have been spending a lot of time on our green roof. So it takes some maintenance. You know, if you install it properly, the main maintenance things are to make sure it's getting. We need some irrigation, so you have to make sure that your irrigation system's working and the zones are properly. You got the proper coverage, because you don't want to lose your plants and your root structure. You need that for the stability of the roof itself. So you need your plants to thrive. We have a person on staff who has a horticulture degree and takes care of our landscaping, named Jess. So she looked at which succulents were thriving, and then we plant, you know, the plan was to replant and really like encourage those plants that are doing well. And the one, you know, it's a learning process. And then most importantly is to make sure that trees don't take root. So that was our biggest key maintenance, preventative maintenance feature, was to make sure the second you saw a tree start, that you pop that out of there quick so that it doesn't take root and potentially penetrate through the roof itself. We haven't had any problems with the roof in terms of the roof leaking. We're investigating right now the fact that our living roof maybe possibly wasn't attached as well as it could have been in the beginning. So we're exploring our options right now on trying to fix some of the structural engineering parts that went into the early design of our living roof. But yeah, it's primarily weeding and watering, just like you would a garden. So does that help?
Yeah, that's super helpful for me. That especially what you said about the trees, just all of a sudden you have this giant, nutrient taking entity, water taking entity as well, that can, do a disservice to other plants that you
absolutely, and damage the roof is the biggest.
Damage the roof.
Yeah, the root systems could damage the roof. I don't know if Chris mentioned it, but we had geese that lived on our roof. They still do. They come and they lay there, they build nests and lay eggs, and we have little goslings jump off our roof every spring, I guess that happens.
Yeah, the geese, it just shows that it is a part of the entire ecosystem. Like we've kind of come full circle in providing safe habitat. And I just wanted to share that it is 11:44.
Okay. Did we get any votes on geothermal or composting toilets or kitchen?
I did not share the poll, unfortunately.
Oh no, I just meant verbally. No, that's okay. Let's do our we're gonna have, if our reception's okay here. Yeah. I'm gonna stay here because we can't really take you, I'm sorry, can't take you downstairs to our mechanical room very well. We lose reception. But I did want to talk about our geothermal heat system. So Rianne, do you want to pull up the mechanical room?
Yes,
3D.
I will. Let me grab that for us.
And I'll go ahead and chat while you do that. So we use a geothermal ground source heat pump combined with radiant floor heating to heat our building. And there's just so many benefits to all those. That's such a long sentence, but the ground loop is 3,000 feet of coils that look kind of like a slinky that are buried in the grassy area out there down below the berm. Those coils serve to capture the heat from the ground itself. So the ground maintains a heat temperature of around 50 to 55 degrees. And so by running this fluid through the coils, we're actually capturing the heat out of the ground, and then we're transferring it using our heat pumps that are in the mechanical room, take that heat out of the coils, and it transfers it into the fluid that's running and radiating throughout our radiant floor system. And then the heat pumps, of course, using electricity, add extra energy to the system to get the water up to temperature.
And I just pulled up the screen share. So yeah, all of these multitude of coils is what Kelly was referencing. I'm not sure exactly which ones
you
are the
probably don't know as well, right? So those, we have a lot of conduit in there, and it's so pretty if you're like an engineer type. So if you can turn it around like 180 degrees, or we can even, keep going around. We can try to see the ground loop piping. You're gonna see I was trying to show that if she gets around to well, I'll just let you keep scrolling while I chat. So a typical furnace, you're using a energy source, whether it's electricity or natural gas, to heat your house, and you're generally capturing 80 to 90% of that efficiency. You lose a little bit in terms of heating your home. With our system right here, we're actually 320% efficient. So we're actually more efficient because we're capturing that heat that's coming from the ground. So we don't have a combustion source in our mechanical room to heat or cool our building, but we have heat pumps that do our domestic hot water as well. Yeah, I was trying to get you, if you keep going, that tank, right, that's our buffer tank for our radiant floor.
This one?
And up above, go up above those closets there. That's the ground loop system. I think you can see it. Oh. Yeah, that's hard to see. Oh, sorry. we're trying to play with our technology right now. So okay, well that is our mechanical room. And then down in there too, we have our inverters for our solar panels. And back behind, we can't see this right now in the tour, but our ventilation room is pretty exciting. So we have 2 ventilation tubes for our building that are about 5 feet wide each. Don't actually know how long they are off the top of my head. And they're pulling in fresh air from outside. That air gets filtered through electrostatic filters. And that's what we circulate through the building when we run our ventilation system. So it's wonderful to have this ginormous, you know, this is such a beautiful area. We're not in a downtown area, so we can pull in all that fresh air from outside. Our filters are great because they're washable. We don't have to throw anything away. So on a frequent basis, we take them down and we wash them and put them back up. And then our ventilation system is an on-demand system. So we have sensors throughout the building that test the carbon dioxide levels. And so the more people and the more occupancy, the more breathing that's happening, the ventilation system will kick on. And that's a huge energy savings for our building. Chris and I are in the middle, especially Chris. We have to worry about the wildfire season out here in Washington right now. So we're trying to build like a portable MERV 13 rated filter that we can put up and take down as needed. We don't want to tax our blowers too much using a higher rated filter, but we want to make sure that the building occupants are safe and nobody's getting headaches. And it's tricky around here in the summer if you have to close up the building when it gets smoky outside. So we're working hard on those solutions right now. Any questions about geothermal or ventilation? Maybe we can try, we have a little bit of time. I don't want to just keep showing you guys videos. We can try to get to the kitchen really quick.
And there's a little sweet little party in there with some staff. Not really a party. We're working here.
Hey, they know we're doing a tour, so.
Yeah.
We're on a tour right now. Well, okay, I guess we have a little bit of a party going on right now. We're on our tour. Okay. Okay, so this is our kitchen. And talking about energy efficiency and especially related to the ventilation system that we were just referring to. This is our ventilation system for the cooking stove. It only comes on based on a heat sensor. So most commercial kitchens, the system will come on automatically and it just runs all day. They just turn it on when they start and they turn it off when they leave. This one will only kick on when the heat gets high enough that it needs to vent the system out. And then you can see our Energy Star rated appliances. Energy Star is a certification program that we have over here by EPA, and they rate appliances based on water and energy efficiency. And then in the back, well, we also have one freezer back there that uses propane as a refrigerant. And propane has a really low greenhouse gas global warming potential, as well as a low ozone depletion potential. So, and propane it's becoming pretty common here to be used as a refrigerant. And then we can show you a few sustainable building features. This counter here is called Paper Stone. It was locally made. Paper Stone uses pressed layers of recycled paper and hazelnut. The counters can withstand temperatures of up to 400 degrees. And it's supposed to be a very easy building material. It's easy to cut on site. And then when it starts to get scratched up, we can do a kind of a sanding and polishing to it and get scratches out. And then down below, we have our bamboo paneling. Bamboo is a sustainable resource because it grows so quickly. And then we have our bamboo paneling on our 4-bin waste system. And I am proud of our 4-bin system. We do on-site composting of our food waste. We also have a few things that can't go in our on-site. We send off to an off-site composting facility, recycling and landfill. I think we're getting close to, do we have questions about?
In the chat, I was just catching up with Han, who was mentioning they may miss the introduction about why this building is so immersive and why, like, is it a community project? Is it just for a specific purpose? And it is kind of all of the above, and the living laboratory aspect, the farm to table education aspect of really seeing like where do our resources go and how can we control our insatiable, you know, thirst as humans to live, sometimes beyond our means. But this place is a really special facility that the more we do these building tours, the more I'm aware of how many aspects, like from cooking to eating to living to playing to farming, and to engineering that we encompass. But that's what's going on in the chat.
Yeah, it is hard to fathom because if you're not, you know, especially if you know the world of sustainability, it's hard to fathom that there's one building that literally has it all. Like, it's jaw dropping. And I remember my very first tour when I came here, you know, I wasn't working here, and it is hard to believe. Our founder is incredibly passionate about climate change and trying to find ways to solve that. And I don't know, I guess Project Drawdown is probably more local. You know, in the US that is, but Project Drawdown is looking for solutions for solving climate change. And agriculture is a huge piece of the puzzle. So regenerative farming practices, reducing food waste, and eating more locally sourced food and eating a more plant-based diet are all really high on the list of solutions for climate change. So we're here, the building is here to help support that and help support the farm. Chris and I have a mission that's to help keep the farmers farming. So yes, we're here for the green building and we're here for green education and about sustainable living, but we're really also supporting this whole entire campus, 21 acres. So.
Yes, that is so well said. That's
Yeah.
awesome. Well, we have 5 minutes left.
Okay, we could show we haven't even gotten a chance to talk. A huge feature is our composting toilets. So I wasn't sure if we won't be able to run down there, but we do have two composting units for our toilets. One for the, well, we have two different bathrooms. And so they are incredibly low use, water use. So they only use 3 ounces per flush. Over here in the US, a typical toilet will use 1 to 3 gallons per flush. So they have a foaming agent. That's the flushing feature. It's not even necessary. It just helps make it look a little bit cleaner when you're using
I'll put the screen share right now.
Okay, that'd be great. Yeah, so she's going to show you the composting units that are downstairs. So our bathrooms are only upstairs because we need that gravity to assist us with our composting toilets. But they've been in use since 2011. We have never had to empty them. So at one point, well, the maintenance that we need to do is to just kind of level everything out once a month, and then a little bit of water goes in there to keep the right moisture level. And then we sprinkle sawdust on there when we do the raking part. And then there's red wiggler worms in there, and the worms and the bacteria eat everything down. It's composted down until we don't have enough solids that we have not had to empty them yet. So, gosh, I'd have to think about it. We probably have, based on what I see, I think we probably have 10 more years to go before we might have to think about emptying them. The leachate from them does get treated in our on-site wastewater treatment system.
Yeah, this, like, when you really understand, like, these 2 giant green bins completely remove us from needing waste stream services, along with the other great water treatment berms that we have around the facility. Like, this is it, and you really are confronted by your waste and to see exactly like what's going on. But the cool part is you don't even see the waste down here where the cursor is. This is where if there is any maintenance to remove and then decide with that waste what you're going to do, if you're going to send it to another composting facility or use it in the landscape as not usually for the farm, but you can. But you can basically, this whole thing is where you can collect from, and there is literally nothing in there besides some cobwebs and some bark. I think there's a couple of like little wood chips in there, but yeah, if this technology could be installed in really high level, high traffic institutions like colleges, anywhere that has 2 floors to account for the gravity that it takes to feed the stuff down the tubes, this would save so much water, so much pollution, and really give back to the ecosystems that we're constantly siphoning nutrients from. But yeah, there's just worms in here and nothing in here because they're such efficient digesters.
Yeah, and in an ideal world, you have what's called a closed loop system. You don't have waste. You know, back in the day, they really didn't generate waste. Things were reused or repurposed. And any way that you can look at what are your outputs like, and how do you make an output an input? You know, what can you do? How do you lower it, and how do you reuse it, such as turning your waste, human waste, into compost and feeding the plants. So, do we have questions about the composters?
Not that I see. Well, we've got I think we've got just 1 or 2 minutes left, so I'm going to see if there's any other final questions, and then until then, we will probably have to break up the call and invite you to enjoy a beautiful weekend.
Yeah, sounds good. Thank you, Rian. Thanks to everybody for joining.
Yes, thank you so much for joining us, and really, really appreciate you again sticking through everything in the intro. But I hope you have a great rest of your weekend, and if you have any questions, feel free to email us at generalinfo@21acres.org, and we're going to send a follow-up email with some resources to explain some more of this awesome technology that's here on campus. Okay, have a wonderful
Thanks, everyone.
Thank you so much for joining us. Take care.
Bye.